Hello everyone, welcome to Pepcoding. So today in this video we are going to discuss question. The question is longest word in dictionary. So what is given in this question? First it is saying that we will be provided with an array of string words, right? Second thing it is saying that find the word of the longest length where all of its substring starting from 0th index exists as a different word in array. So here is a test case given. Let's see what this line means by applying this line on this given test case, right? So here we have the test case, same sample test case. So what that line means is that we have to find the longest word given in this dictionary, right? Let's say this is a dictionary of 7 words. So we have to find the longest word where all its substrings are present as an individual word. So what this means is, let's take this as banana as an example. BA, right? If we take banana as an example and if we try to search for all its substrings, so what are going to be its substrings, or let's say what are going to be prefix for this banana word, right? Let's start from this point. For A, the prefix is going to be these thing, that is this substring. That is, for last A, let's give them indexes 1, 2, 3, 4, 5 and 6. For A present at 6th location, for A present at 6th index, what is going to be its prefix? That is what is going to be its substring. That is going to be BANAN, right? 1, 2, 3, 4, 5. So for this A at 6, the substring or the prefix of this A is going to be this string, right? Similarly, if we take this N, that is at 3, for N at 3, the substring or the prefix is going to be what? BA, right? That is 1, 2. So now if we see it in a proper manner, that is starting from B to and then going to A, then how it is going to look? I'll erase this so that you will not be confused. For this banana, the prefix is going to be something like this, or all the substrings of this banana are going to be something like this: BA, BAN, BANA, BANA, and banana itself, right? Banana itself. So now if we try to search for all the substrings of this banana in this given dictionary, then we can see that only this thing, that is the banana, is itself present, but not the other strings, right? Not the other strings. But similarly, on the same hand, if we take an example for, let's say, apple, right? We can see that this is the longest word in the dictionary, but it's all the substrings are not present. So this cannot be our valid answer. But let's see what others can be our valid answer. If we see this apple, or let's say if we see this apply, can it be our valid answer? Let's write all its substring. It is going to be A, AP, APP, APPL, and APPL, right? So here we can see that if we compare all these substrings with the given words in the dictionary, let's see if all the substrings are present or not. A is present, right? Then let's search for this. Next thing is going to be APP. APP is also present. APPL is also present. AP is also present, and apply itself is also present. So from this we can conclude that there is a word that is present in this dictionary where all its substrings are already present. That means, and all those substrings are individual word. Let's say, what does this individual word means? That this A is an individual word. A is as a substring is also an individual word. APP is an individual word in this dictionary, and as being a substring of this apply, APP is also an individual word if we consider it as a substring of this apply, right? And others are also following the same property, right? So we can say that this apply is a possible answer, right? It holds a value, or it holds the chance to be a possible answer. But if we look for another word, or if we go further and look for this apple, it is also having all its substring, right? If we say that A, AP, APP, APPL, and APPLE, right? Here we can see that A is present, A is present, A is present, AP is present, AP is also present, APP is also present, APPL is also present, and Apple itself is also present, right? So with this we can say that this Apple is also a valid answer. So here we are getting two answers, right? Apply and Apple. But now let's see that what is further told us in the question. It is saying that if there are multiple answers with the same length, return one which is the smallest lexicographical order, right? And if there is no valid answer, just return an empty string. So what is this meaning? What this sentence means is that if we are getting two answers that are having same length, have the possibility or are the possible answers, that is apply is also a possible answer, apple is a possible answer, then return the answer or return that word that is that is smaller if we consider the lexicographical order, right? So here we can see that here we can see that E is smaller than this Y, therefore lexicographically Y is bigger than this E. That means Y comes after E, therefore we have to return this apple one, that is with this the word that is ending with this E, right? Therefore we have to return this apple. So with this I hope the question was clear to you all. Now let's try to discuss the solution. First, if we try to do it with a brute force method, what can be the brute force method? We can just go iterate on every word and check for the longest subsequence or longest substrings for a word. Like if we take apple, we can just go and check for each and every word that if the substring is a substring of apple is present in this or not, right? This is the first thing we can do. Now let's see for the second thing, that is the best approach that we can use. That is going to be what? Here, if we try to observe something, we can see that this part, right? Let's highlight this part, and this part. These two parts of our possible answers are equal, right? Are common in nature, which means that we can use these two parts, or we can say that we, instead of traveling these two parts again and again, that is for two times, let's travel them only once, and where these two parts are changing or are having two different answers, let's just give those two parts different places, right? What I'm trying to say is that let's use the concept of try. Let's make a root node first. Let's use this example, that is use this test case. Right, first take this A. We took this A as an individual word, right? A is an individual word, so this A return of this A is over. Now this banana, let's take this banana where B is the starting letter, A, N, N, A, right? Banana. Here this A is the ending letter, which means that this banana is an word where B is the starting letter and A is the ending letter. But this is not an valid answer because this this B, A, N, A, N, these are not the individual words that are present in this given dictionary, right? Now let's talk for app, that is P, P. Here we can see that this P is the ending letter, right? Now let's check for this APPL. Now here if we see from a root node, we are able to see that A is common, A is common. We already have this P, we already have this P. We again have one P. So what is not there? This L is the only thing that is not there. So we can just add this L and we can just use this rest of the things, right? Here this L is going to be the ending point. Similarly, if we come for this A and P, that is AP, Here we can see that from our root node we already have A and we already have P. Then just consider this P as an word, or let's just consider this P as an ending letter of a word. So that word is going to be what? That word is going to be AP, right? And next, if we go for this apply, we can see that there is a word that is coming, or that is actually coming, we can say that there is a word that is coming after this substrings, right? And there is another word that is coming at this place, right? So with this, what I am trying to say is that there is a word, or there are two words, or I'll just try to rephrase this thing again. We can say that these thing or these substrings are common, and the work is being divided for this L. That is, L is having two children, that is E and Y, where this part, that is, this part is making one word and this part is also making one word. So here we can see that this particular part is common part, or we can call it as a shared node, right? And the work is being divided for just E and Y. So what we can do, we can just travel from this root, we can just travel from this root and start making our answer, right? And as we travel, we are going to actually use this concept, or this thing of travel and change. We are going to use this travel and change strategy, where we are going to make our answer as in global or static answer, and we are just going to travel through all the substrings, and we are going to change, we are going to make changes in our answer, where we are going to store our answer in which manner? In a lexicographical manner. That is, first we are going to start from A, and then we are going to move from A to Z. Therefore E is going to come on this left side of L, and Y is going to come on the right side of L, right? Why is this happening? Because we are traveling in lexicographical order. So with this, if I start making my answer, that is, from E I am going to use my DFS. That is, from E it is going to return to L, from E it is going to return to L, and from L it is going to come to Y. But as we are moving in lexicographical order and we are using DFS at this particular point, what is going to happen? Or when we are going to change our answer? Our answer is going to be only changed when, or when only updated when our answer's length, that is, if we say that if my current length, that is current words length, if my current words length, that is after traveling till here, till Y, is going to be greater than my answer's length, then I am going to update my answer, right? Update my answer. So what I am trying to say is, I am trying to say that as we are moving in lexicographical order, right, we are going to store our answers in lexicographical order. So first, what is going to happen? First this A, P, P, L is going to be created, right? And then it is going to check for A, P, P, L, Y. That is, from the C it is going to check for Y. But as in lexicographical order, E is going to come before Y. Therefore, it is going to consider this as an valid answer. But if there was a case where this Y was going to have some word or something like, let's say A, B here, right? If Y was going to have, or instead of A, B, just let's say Y was going to have B, some B here, then the word, let's say it was something like APPLYB, appleb, right? Anything like this. That doesn't make any sense, but just for now we are taking an example that if there was a word something like this, then our longest substring or longest answer or longest word is going to be what? our longest word was going to be this APP YB. Therefore, after coming from here, that is after applying DFS here, it is going to check for Y. It is not going to update. It is not going to update for this Y. But when it goes to this B, what it is seeing that our answer's length, till now our answer is apple. But now my current length, that is current word's length, is greater than my answer's length. Then it is going to update, because we have to do what? We have to return the longest length. We have to return the word of the longest length, right? Longest length of the substring starting from 0th index exists as a different word in an array, right? So if there was a word something like this, if there was B also present here, then this B was an individual word. Also B was something like this substring, right? So substring for this apply or this word was going to be this apply and this B, right? Therefore it was going to be the longest substring, right? Therefore our answer is going to be updated from this apple APP LYB, right? So I hope this is clear to you all. So therefore, but as currently we don't have this thing, we don't have this applet, therefore it is not going to update our answer. It is going to keep answer as apple only, right? Because we are going to store in lexicographical order. So with this, I hope this is clear to you all. What we are going to do, actually we are going to just use this word, that is or we can say that use this part as in common part, or a shared, we are going to store this in a shared node, and where the work is being divided, we will just work for that thing and we are going to apply DFS over there. So let's now try to code this thing and see what is going to happen while we what is going to be a code structure for this thing, right? So let's start coding this question. Okay, so here we are provided with three functions, that is DFS, insert and longest word. We have to complete these things. So from here longest word is being called, right? So first thing what we have to do, first we need a root, or we need a node. Root is equals to new node. Using this node we are going to travel, that is we are going to travel and we are going to keep on creating new nodes when the words are being common, and that is we are going to use this thing just to create a shared node, right? That is the easy thing we can say. Now we are going to travel on all the words or all the strings that we are going to get, that is from words, and we are going to insert them. Insert yes, this is going to insert the respective values of string in a root node, right? And after that what we are going to do, we are going to call DFS on root, that is we have to travel from here to here, and we have to just travel and create our answer, right? Our answer is already being given as a global variable, right? And from here we have to return return our answer, right? Now first let's complete this insert function. So what this insert function is going to do, it is going to travel on all the, that is it is going to travel on all the words, all the single letters of a given word. Let's say for this first thing, or for this thing, it is going to first travel on A, then P, and then P. For this banana, it is going to create a new string or something like this by traveling on this B, A, N, A. But here you can see that A is already present. Or for this let's consider for this. Let's see for this app thing. Here we can see that A is already present. That is A have been if we come to this point, A was already been traveled, or the node for A was already created. So therefore it is not going to create a new node for A, but it is going to create a node for this PP, right? We want something like this, that it should not create another node for A, but it should directly create a node, create two nodes for PP, right? So to do that, what we are going to do, first we are going to I is less than stop len pth, sorry, not len, size. This means that we are going to use it only, we are going to travel, or we are going to run our for loop till size of this thing only. So size by plus plus. First what we need? First we need what? First we need this A, right? First we need the first character. So we are going to make a char ch is equals to s dot at I, right? This will give us what? This will give us this A. Now what we are going to do? We are going to check that if our A is created or not. So how we are going to do that? If this current node that we are having from here, that is we are receiving a current node, if this current node's child has this character or doesn't have this character, let's say doesn't have this character, that is it is null, then do what? Then create a new node, of the same thing, that is equals to new node, right? What this is saying, telling us that if this A was not created, here A was already created, let's say for this P, if this P was not created, do what? Create a new node for this P, right? It did that only. And if it is already present, just update it. So current is equals to current.root, right? And after this for loop, just update our current string to this S, that is the string created after this, right? From here there is going to be create a string created of nodes, that is going to be this part, and just update this with our current string, right? Now let's come to this DFS function. What this DFS function is going to do? This DFS function is going to help us to travel from this point to this point and from here to here, right? So what we are going to do here, we are going to travel, that is for node, let's say child, that is going to help us travel in this root's child. That is, first we have to check that if we have some answer, that is if current, not current, but if our child is not null, right? Not null, and then it has some answer, which means that this child str, sorry, is not equal to an empty string, then do what? Then check for this thing. Check for this thing, that is before updating our answer, check for this thing, that is array.len. If my current answer's length is greater than if my current length is greater than my previous created answer's length, then update my answer. So for this, what we are going to do, we are going to check here. We are going to check that for child str.size is greater than my answer.size, then do what? Update my answer, that is answer is equals to child's str, right? And then apply DFS on what? DFS on root, but child. Why child? Because from this point we have to move to the child of from L, we want to move to else child, that is going to be, then we are going to move to Y. So from here we want to apply DFS, therefore we are applying DFS on child. With this, our code is complete. Let's try to run this and see if there are any errors. Okay, there is an error. Value required as left operand of assignment. Let's see on 20, line number 20. Okay, yes. Yep. To give this. Right, let's see if there are any other errors. Okay, node.child 28 8 28 28 28. Here it is going to be star as pointer. Now let's try to run this code, and it is being accepted. So there were just minor errors, those were syntactical error. So our logic is working fine. Let's see if all the test cases, yes, all the test cases are passing. Therefore, I hope that this video was clear to you all, and what we actually did in this question. Actually, we just created a common shared node, and where the work was being divided, we just created those two nodes, and we updated our answer only when our current answer or current answer's length was greater than our previous created answer's length. That is, we are applying travel and change property, because what we are doing, we have already created this as a global answer. So this will be updated, or we can say that this is not going to be updated again here. Whenever this condition is being true, then only it is going to be updated, right? So with this, I hope the question was clear to you all. So thank you for this video. Let's meet in the next video.